Hi, so my name is Natalie Leger, and I'm going to be explaining epistasis, a genetics phenomenon, when the expression of alleles at one gene mask or modify the expression of the alleles from another gene. So this is an interaction between two different genes, two different loci, and not between two alleles from just one gene. So these interactions between multiple genes create just one phenotype. So when can these alleles or genes be considered epistatic? So epistatic is when they mask or modify the effect of another gene. This can be compared to dominance of alleles, like capital A versus lowercase a. So the types of epistasis are many, and this depicts just 6. So we can see here that this chart is saying that these genotypes have different phenotypic ratios. So the reason that they're changing is because they are all modifications of the Mendelian ratio, which comes from Gargo-Mendel and a dihybrid cross, and its F2 progeny. So epistasis can be seen in mice and their coloring. So single dominant epistasis is when the allele is epistatic to the alleles of the first gene and the second gene. So here we have our introduction of this epistatic allele, which keeps our colorless precursor mouse from becoming a gray intermediate. If it's not expressed and instead we have the lowercase a, we will reach our gray intermediate. If we want to get our purple end product and the mouse turns gray to purple, we have the expression of capital B from our second gene, but if the lowercase b from our second gene is expressed, it inhibits the gray intermediate and it will keep the gray intermediate, no purple end product. So what does this look like when we cross our genotypes? So this genotype is crossing with itself, and these are the different combinations of alleles. So putting that into a cross plot, we get all these different combinations of the F2 progeny. And the F2 progeny create this ratio of the different combinations. So this is our Mendelian ratio, but it changes because we know that single dominant epistasis is regulated by one epistatic allele, capital A here. So we get these combine and create 12 white or colorless precursor, 3 purple, and 1 gray intermediate with the double B inhibitor. So that looks like this. This is our ratio. Using a different genotype to cross, these are our allele combinations. This is our plot, and we get this ratio. And that looks like this.